Jeannie, what sparked your interest in Fragile X technologies?
I've been interested in Fragile X for a very long time. First, as a PhD student at the University of Pennsylvania, where I trained as a physician scientist. And there, my PhD work was directed at understanding this unusual inheritance pattern for Fragile X. And of course, this was back before there were trinucleotide repeats and before FMR1. What really caught my attention as a student was the fact that the syndrome can only be passed through the maternal lineage, which was very odd. And it had all the markings of an imprinted disorder. And in fact, Fragile X is an imprinted disorder, meaning that the parent of origin has an effect on the gene. And this unusual pattern of inheritance and the fact that it's X-linked is actually what led me to X chromosome inactivation, which has been my lab's main focus for the past 20 plus years. And as we've gotten a better understanding of the basic mechanisms behind X inactivation, we've become interested in leveraging that understanding towards treating X-linked diseases. And those diseases would include not only Rett syndrome, which is something we've been studying for 10 years, but also Fragile X syndrome, which brings me back full circle to my PhD work. And so these past 10 years or so, we've been working on two technologies to address the symptoms in Fragile X syndrome. And both of these technologies, well, one is more specific for Fragile X, and the other is something that could be applied to a number of different X-linked diseases. And so yes, I've been interested in developing Fragile X therapies for probably 3 decades at this point.
So what is the approach that you're working on, and how does it differ from existing treatments for Fragile X syndrome?
I mentioned that there were two technologies. They're actually very different. They're focused on different targets. So the first one is what we called a selective X chromosome reactivation. And I should mention that this is a technology that we envision working in girls with Fragile X syndrome, as well as girls with other X-linked diseases. And I can say a little bit more about that in a few minutes. But the other technology is much more specific for FMR1. So we call it FMR1 reactivation. And this one can be applied, if it's ever successful, can be applied to both boys and girls because it selectively addresses the mutant copy of the causal gene, which is FMR1. And so you asked the question, how do they differ from existing technologies and existing medicines? And well, the reason we're excited about these technologies is because they really target the root cause of Fragile X, which, as you know, is the absence of FMRP, which is the protein product of the gene FMR1. So unlike the currently available treatments, we're not targeting just the symptoms or individual symptoms of Fragile X. We're actually getting at what is responsible for these constellations of symptoms to begin with.
So can you explain what the X reactivation technology actually involves, Jeannie?
Yeah, right, so there's X reactivation. And so this stems from a realization that we and others had, going back many years now, which is that girls with Fragile X syndrome and other X-linked diseases actually have the cure within their own cells. Now that sounds a little bit odd until you realize that, so girls have 2 X chromosomes, whereas boys have 1 X chromosome. And so it happens that in order to equalize the gene expression from 2 versus 1, the girls inactivate one of their X chromosomes in early development, before birth, long before birth. And so what this means is that girls and women in general will carry around an extra X chromosome their entire lives in a dormant state. So it's not utilized at all. We just carry it around like a extra baggage. But But since that chromosome has a lot of good genes, it occurred to us and others that we could potentially utilize, maybe turn back on some of those good genes on the inactive X to treat the disorder that is caused by the bad gene on the expressing X chromosome. And so FMR1, as you know, is on the X chromosome. And girls have 2 copies of it, boys have 1 copy. So we have now discovered a way to unlock the dormant FMR1 gene on the inactive X chromosome. And we do that without getting too technical here. We do that by targeting a non-coding RNA called exist with an antisense oligonucleotide. So it's a very short nucleic acid. And that interrupts the ability of exist RNA to maintain X chromosome inactivation. So we now have a proof of concept in cells and in animals that we can get this to work and restore, partially restore, not fully restore, but partially restore expression of these genes by a few percent to maybe 20%, which we believe can be therapeutic. And so the other really exciting thing about this is that the treatment would only have to be given 2 or 3 times a year, right? So the families would show up with their children and go to the hospital 2 or 3 times a year to get a booster shot. And hopefully that would last, for another 4 to 6 months. So if this ever became a therapy, and we're hopeful that it could, I think it would be a game changer for families.
So for parents of children who have Fragile X syndrome, what do you think the Fragile X treatment landscape will look like for them and their children in 10 years' time?
Right. So, biotechnology is progressing at a rapid pace. I think that the treatment landscape will continue to evolve at a very rapid pace over the next 5 to 10 years. So, as you know, there's a very healthy pipeline of medicines that are already in the clinic, right? And these medicines are important because they treat the different symptoms associated with Fragile X syndrome, the autism, the anxiety, the seizures, if they're present in the girls and the boys, muscle spasm, a lot of things. I think it's very important to have better and more types of treatments for these symptoms. And so I see a lot of that coming through in the next 5 years or so. Ultimately, though, I think we want to try to get at the root cause, right? Because by treating the absence of FMRP or FMR1, absence of its expression, we will have the best chance of hitting all of these symptoms at once and not having to go to have this situation of being in a polypharmacy where you have to take 4 or 5 different medicines, a day in order to alleviate all of the suffering. So I think if we can project out to 5 or 10 years, 15, whatever years from now, we're going to be looking at different ways to restore FMR1 expression. And so perhaps, we might see something in 5 years because we are hopeful about the X reactivation technology. There's another technology I haven't mentioned, which I think will be equally important. That's the area of gene therapy. Various challenges associated with the AAV delivery, the viral delivery. There are issues with overexpression of the genes which are introduced and how many cells in the brain that you can hit. But I think that in the next 5 to 10 years, we're going to see tremendous progress in that space as well.
Thank you, Jenny.
Thank you very much for your time.